Welcome. This is the uh, 2.1 Practice 2 AP Chem solutions that we've got going on here for the Practice 1. So the first one, we want to write a balanced equation. You can kind of see some of the arrows that I have, and I'm going to be pointing to them. But we want to write a balanced equation, so I read through this whole thing first, and then I went through and wrote it up. And so I'm going to just have my pointer here so you can kind of see where I'm going with some of this. And so we can see that it's aqueous. Aqueous, we're going to put all aqueous in our solids all after it, or liquid, kind of thing here, our gas. So we're going to have 2 KOH. Remember, this is NO2, NO3 is going to have a 1 charge, Hg2 plus because it said so. Strontium sulfate, we're going to have mercury sulfate. We're going to have strontium hydroxide, KNO3. So we're going to write it up, and if it's aqueous, we're going to break it up. So this is actually potassium plus, OH minus, plus Hg2 plus 2NO3, strontium 2 plus, sulfate 2 minus, mercury sulfate, strontium hydroxide. We're going to see that the spectator ions are the ones I crossed out. That's that potassium right here, because it shows up as well as over here, and our nitrate over here, as well as over here. So our potassium and our nitrate in this reaction are going to be the ones that are going to be our spectator ions. For the ionic one, this is the one that's left over, as you can see right down there. So that's a net ionic reaction. That's the things that go from ionic to a solid, liquid, or gas. It cannot be broken up any further. So I wrote down this equation again by looking at this first number 2. I wrote down this equation, as you guys can see. I had the aqueous, and I wrote it all out. And so what these videos here, just as a reminder, they're supposed to be able for you to pause, look at your notes, look at what you did, and then compare, and then kind of keep going and work your way through it. So that was number A. I actually just wrote right up here, so I had a little bit more space when I did it. Breaking up anything that's aqueous, I have zinc 2 plus 2Cl minus Hg2 plus 2NO3 plus 2K plus 2OH, yielding ZnOH2, because that's solid, we cannot break it up, HgCl2, which is solid, cannot break up, 2K plus and 2NO3. So I also again cancel these guys out, the KNO3 and the K plus and the NO3 minus, because those are going to be the ones that are going to be canceling. Those are the spectator ions. These are the guys that I canceled out. So again, NO3 and K plus, those are the ones we can cancel out. So write a net balanced equation forming zinc solid hydroxide. So we don't care about the other things, we just care about those ones that are forming zinc hydroxide. So we just look at those things, and that's going to be zinc and hydroxide coming together to form it. And then for solid mercury 2 chloride, we just care about those things that are forming it right there. And so again, the spectator ions, the ones we cancel out on both sides, is K plus and NO3 minus. Now looking at the following equations, I actually miswrote something right here. Okay, so I just want to kind of talk my way through this one so you guys can actually kind of see it. So let me grab this one here. Let me grab my highlighter in yellow. So because this molecule is so big, we want to kind of assume that molecule is going to be 1 for a coefficient. That one's kind of big, and so we're going to start that because it's a really big molecule. It's a lot of hydrogens. We're going to have to scale everything up to that. So you could take carbon, you could take hydrogens. It doesn't matter where you start. I'm just showing you how I did it. I'm going to look at hydrogens. That's just a personal preference of mine. And so this is going to be, there's already 2 H's on this side. And I don't start with hydrogens. Don't because there's, or I mean oxygens, because it's in 4 out of 5 of these things. So it's going to be hard to balance. So there's 22 hydrogens here. There's already 2 over here. So to make it balanced, I have to multiply by 11. So I've got 22 here. So the one that we know about so far is the one I've circled, is this 11 right here. So that seems great. Now let's go back to what we were just looking at with that big molecule, and I've got 12 carbons here, so that means I have to have 12 carbons here. Multiply by 12. Looks great. Now let's go ahead and add up the oxygens on one side and compare to the other. We've got 12 times 2 is 24 oxygens plus 11 oxygens. 24 plus 11 is going to give me 35. On this side, I have just 11. So we have to make this O3 work. And so that's where I got this 8. So 8 times 3 is 24, plus 11 is going to be 35, so it balances. So I've got 8 potassiums, so I must have 8 potassiums, Cl, and the 8Cl. So in order, our coefficients should be 8, 1, 8, 12, 11. And you guys can kind of see my process. You guys can kind of work through it too if you guys have any questions. Okay, so I'm going to look at this next one. So I have I just like to look at things that are in one side and then one on the other side. So I've got 2 aluminums, 2 aluminums. Looks great. This is fantastic so far. So that's cool. I have 3 of the CO3s. I only have 1, so I must multiply this by 3. Hence why I have that 3 out in front. I have 3 times 2 potassiums. That means I must have 6 potassiums. Now let's just double check our chlorines, and we do have 6 here, so that is completely balanced. So again, our numbers here should be 3, 1, 6, 1. Going for the coefficients right in front. Sometimes they might ask you, what is the addition of all the coefficients? So in this case, it'd be 3 plus 1 plus 6 plus 1. So 4 plus 6 is 10 plus 1 is 11. They might ask you to add them all up. Or they might say, what's the coefficient in front of this one, KCl? That'd be 6 after you balance it all, but you would have to still balance it. So you want to make sure you always balance these equations and start with one, kind of work your way through, and it's a maneuvering process. And I know they have a lot of practice with this. If you do have questions, though, I do have a lot of extra worksheets I'm willing to hand out to those individuals who need help. So let me know. So let's go ahead, and on this next one, I kind of wanted to start off with the H's, and you'll see why, because I've got here, I want to make it whole numbers, so I've got 6 on this side, but I've got 4 over here, so I have to know what does 6 and 4 both go into, and that's 12. So let's just make this go up to 12, and this is just a guess, but we have to know that they have to be scaled by some factor. And again, if you do it a different way, that's totally fine. I'm just showing you my answers. So 3 times 4 is 12, because I know that they have to multiply to get to the same thing eventually. So 12 on that side of hydrogens. And we've got 2 times 6, so that's 12 hydrogens. Great. So now let's look at our borons. So we've got 2 times 2 is 4. So let's take 4. Let's look at our fluorines. We've got 4 times 3, which is 12. So I must have 3, that's 9, but remember I have this guy out here. So I'll put a 3 out in front. Remember we already have this 3 out in front here, so that's 3, 4, 3, 3, 2. So this one does balance. It's kind of a weird one. I went ahead and started off with the hydrogens. You can start off with anything, but the key trick here is that if you start balancing them, if you have anything that is divisible by 3, so let's say like if it goes up to a 6, like on one side you have 3 hydrogens, on the other side you have 2. You want to make sure it goes up to 6. Find the lowest common multiple. Or here we had 6 and 4, and so we want to find the lowest common multiple. We found 12, and so then we multiplied up to get up to 12 for the hydrogens. So that's kind of key. So again, 3, 4, 3, 3, 2 are going to be the coefficients right up front. So our chemical equation be balanced. This is so we compare the mole-to-mole ratios. We can go from one thing to another and calculate grams and do our various calculations that we need to. Again, if you guys have any questions, please let me know. I know this one went really fast, but definitely you do need to be able to practice these balancing equations. These are really big for the AP exam. We have a lot of these written ones. All right, well, thank you guys.